Okay, this is a short video on mechanisms for junior cert engineering and junior cert metalwork students, just to introduce the common types of mechanisms found today. So if we start off by asking what is an actual mechanism, and a mechanism is any mechanical device such as gears, screws, pulleys, whose primary purpose is to translate one kind of movement into a different kind of movement. So if we take, for example, a bicycle, when you pull on the brake lever, that pulls on a cable which closes the brakes of the bike. When you press down on the pedals, it turns this large gear here, and through a chain turns the back gear, which causes the back wheel to turn. So both of those would be examples of mechanisms that are found on a bicycle. Now, mechanisms do not work by themselves. They need something or someone to actually get them to work. So the work that you do, so if we take, for example, the pliers here, the energy required to get it to work we call the effort. The actual work that's done, in this case the pliers gripping something, we call that the load. Now if we look at the trolley jack here that's jacking up the car, the effort is here, that's what's pushing the car up. Sorry, the load is there, that's what's pushing the car up, and the effort is the person pulling down on the lever to actually get the jack to operate. Now, we can't talk about mechanisms without talking about motion. Now, motion is simply a word we use for movement. Things don't move on their own, we have to get them to move. If we want something to speed up, that motion is called acceleration. If we wanted to slow it down, we call that deceleration. Now, let's have a look at some of the different types of motion. There are four main types of motion that can be found in mechanisms. The first is linear. This is straight line motion, where the motion goes in one direction and one direction only. So if we take in the engineering workshop, the vice jaw, when it's closing, is moving in a linear fashion. It's moving from open to closed. Now, reciprocating is slightly different. It is still a straight line motion, but this time it is constantly moving forwards and backwards. And the best example in the engineering room would be a hacksaw blade when you're cutting. So a hacksaw blade moves forwards and backwards as you are cutting. The next type of motion is rotary motion, anything that moves in a full circle, that actually completely rotates. So a good example there would be a motor spinning or a propeller spinning or something like that. Now it can spin either clockwise or anti-clockwise, but the important thing is it is only spinning in one direction at a time. Now, the last one we have is oscillating motion. This is where motion moves in an arc. So it moves in a swinging motion, like a child in a swing, left and right, but it doesn't complete a full circle. If it completed a full circle, then that then becomes rotary motion. So here we have a couple of examples of the different types of motion. So I've already mentioned the motor here. So the motor here would be a perfect example of rotary motion. The pendulum on a clock swings in an arc left and right, so that makes that oscillating motion. The person here with the bow and arrow, when they release the bow, the arrow flies in a straight line away from the archer, so that's a perfect example of linear motion. And then finally, the rack and pinion we have here, which we'll come back to later. As this wheel turns in circular motion or rotary motion, this moves left and right, which means the pinion, the straight bar, is showing reciprocating motion. Now, when we're talking about mechanisms, we need to be aware of a number of different things. First of all, we have the load. The load is whatever force is applied by the mechanism. The effort is the force applied by the user. Now, this is important because the difference between load and effort is what we call mechanical advantage, and mechanisms can give us a mechanical advantage. So for example, if the amount of load that's applied by the mechanism is twice the amount of effort I put in, then that mechanical advantage would be 2, because the force out is twice the force in. We'll look later at why. Now, there are lots of different types of mechanisms, and we're going to look at some of these in this video and some of these in the next video. So you have levers, linkages, cams and followers and so on. So we'll be looking at all of these so you'll be able to identify them in a future lesson. So we start off by talking about levers. Levers were first invented in the Stone Age, so thousands of years ago, as a way of moving rocks and boulders. And people discovered through trial and error that if you have a pivot point, you have a long piece of wood at one end and a short piece of wood at the other end, a person who's relatively strong but not very strong can move something that's many times their weight. And this is the first example of mechanical advantage. Basically, the shorter the distance from the fulcrum to the to the load, the shorter that is, the more force you have, particularly if the distance between the effort and the fulcrum, the pivot point, is long. The longer that is, the bigger the mechanical advantage. So, there are three basic types of lever. You have a class 1, a class 2, and a class 3. And the way to figure out which is to look at what is in the center. In a class 1 lever, the pivot point, which we call the fulcrum, is in the middle. A good example of this would be a claw hammer or a seesaw, like the diagram here shows. For a class 2 lever, it is the load which is in the middle. Now, best example of this would be a wheelbarrow. The effort is the person carrying the wheelbarrow. The load is whatever is in the wheelbarrow, and then the fulcrum is the pivot point at the axle of the wheel. And then the third type of lever is a class 3 lever, and in this one it is the effort which is in the middle. And a good example of this is a fishing rod. The person holding it here is providing the fulcrum. The effort is you pulling on the fishing rod, and then the load is whatever fish you've actually caught. So that's actually an important one. Now there is another one. The human arm is also a class 3 lever, but a fishing rod is a very good practical example of how that works. Now, levers can be used in a lot of different ways. The most common way we use levers is to actually create and build linkages. A linkage is a mechanism which we create by putting together a series of levers. So if you take this example here of the reverse motion linkage, this reverse motion linkage is a simple class 1 lever because our pivot point is in the middle, and as the top arm moves to the left, the bottom arm moves to the right. So it's reversing the direction of our levers. This is used in a lot of common mechanisms. We also have a parallel motion linkage where these two linkages here and the top linkage will always remain parallel, and these two linkages here will always remain parallel. This is used in security gates and things like that, and this here is called a bell crank, and this is what's used for your bike brakes. There is your fulcrum. Here is your effort caused by pulling the cable up, and then your load or your force clamps on the bicycle rim. Now, we'll finish up this video on all of this introduction, and in the second video I'm going to produce, we will look at cams and followers and other types of mechanisms, as well as looking at gears and gear systems and gear ratios and things like that. Okay, thank you.